Hey guys, welcome to the fourth and final part of the tutorial, which is going to be based around shaders. For this part of the tutorial, what I want to be doing is getting a shader to go over the entire screen to give my SWAT character the impression of night vision. So we're going to be looking at getting a shader onto the first person camera and hopefully getting him to be able to see in much darker situations. So the first thing we're going to want to do is head on over to the first person camera and set up the Boolean value which we looked at very briefly in one of the last tutorials, which we left in, which was the night vision Boolean. In here we're just going to literally put a switch into the camera movement function, which is just going to be a check night vision function, which will just change that Boolean on and off, and I'm going to hard code that to the value n. We've seen across this course a few different ways to get different keys and be able to manipulate them in the inspector, but for this one I'm just going to hard code it straight into n, and that's all we actually need to do in any existing code that we've already got. So we can save that down and head back on over to Unity. Now back in Unity, I'm going to set up a brand new folder for all of our night vision stuff. So if we set up a folder for night vision, and within this folder I'm going to need three different things. So I'm actually going to need a new script, which I'm going to call night vision image effect. I'm also going to need a shader, which we will make a standard surface shader, which is fine. We're going to remove what's in it anyway. So vision effect shader, and I'm also going to need a material that we can assign to. So I will call that night vision material. Okay, so that's everything that we actually need for our night vision. The first thing that we're going to do is go into the script and actually program how we want our night vision to come up. So if we remove our start and our update function for the time being, and as with all the other functions that we've written, we're going to want some variables placed in. So if we drop those in first, we're going to want access to the camera, we're going to want access to our night vision material that we've just created, and we're also going to want access to our first person script to see if that Boolean value has been changed. Our first function in here is going to be on enable. On enable, we're going to get the component for the camera. We're going to make sure that our camera is actually rendering out a depth texture. The depth texture is pretty much what we're going to be basing our night vision on, so we need to make sure that we've got that rendered, and we're going to assign the first person camera. Next we're going to want an on image render function. So when the image actually renders, we're just going to check to firstly see if the first person camera Boolean value, the night vision Boolean value, is true. If so, we're going to use a graphics split to copy the source texture from the screen into the destination render texture, with a shader passing through our effect material that we're going to assign in the inspector. That's everything that we actually need in script, so we can save that down and actually head on back to Unity again, and in the first person camera we can just assign that script straight in as a component, and down here where it's looking for an effect material, we'll just assign our night vision material straight to that as well. At this stage it should technically work. We press R to okay, cool. So if we want these to change while we are in edit mode, what we're going to need to do is go into our night vision script and just add a few additional functions, basically just some effects to make sure that we can actually see what's going on. So we're going to want to make sure it executes in edit mode. We're going to allow the effect to be viewed in scene, and another one worth adding is going to be just before we render our image, to render the image effect opaque. The image effect opaque just makes sure that the attribute gets rendered after all of the opaque geometry, but before any transparent geometry. So where we're looking for a fairly flat image with any lighter areas magnified with a kind of a green hue, we just want to ignore pretty much anything that's that comes through as transparent. So let's save that down and head on back, and let's give that another shot. So if we come in, there we go, and we press R to go into first person mode, and then we press N, we get a completely black screen, which is perfect. So that means everything's working. We just now need to actually build the shader. So if we open up the shader, and this is just default shader, we can pretty much get rid of all of that. We're going to kind of write ours from scratch. So first off, what I want to do is actually just build the shell. So ours is going to be a shader. We'll give it a title in a minute, and it's a function. Now the title itself will essentially build where it's going to live in our folder structure, which there is showing up now. I don't really want it to show up. Because of the nature of it, I'm not really going to use it for anything else. So I'm actually going to make it hidden. And then night vision effect shader. There we go. Cool. So that's going to be hidden, and that's just going to be the name of it. After that, we're going to have our properties, which again is a function. Now in here, this is everything that our shader needs. Everything that you put in here also shows up in our inspector in the top corner. So if we've got colors or anything that we want to change on the fly, this is where we can put them in here. But let's build the shell first, and we'll come back to that. So after our properties, we have our subshader, which again is a function. From here on out, we're in Shader Lab. Well, we're actually in Shader Lab right from the start. So Shader Lab is the Unity's shader language. It's not C# or Java. It's actually a shader language written by Unity, which we stay in right until we get down to our next section, which is our pass. So there can be several passes in shader. In this instance, we're only having the one pass, which is going to make our lives slightly easier, but you can have pretty much as many as the system can handle. But when you go into a pass, we're actually going to change to a CG program, which is a completely different language. The CG program language is actually C for graphics, and was written by NVIDIA. So it's slightly different, which just going to keep you on your toes. So everything between our CG program and our NCG is going to be in this CG syntax. And within here, I will put these in now, even though we're only actually building the body, but we need to actually make two pragmas as instructions to tell Unity what it is we're looking for and where, and those two are going to be our vertex and our fragments. So if I drop those straight in, we use pragma essentially as a define almost, and just refer to them as vert and frag, which tend to be sort of the generic, but you can pretty much call them what you want. I'm also going to need throughout this an include into the CG include library for a few of the different functions. Following that, I just need my structs for my vertex input. There we go, and a struct for my vertex output. There we go. I don't know why it's misaligning my brackets. It's fairly frustrating, but there we go. And then we just need our vertex function. So let's just make a note of these. So this is our vertex output function, which is going to take a vert, and it's going to pass in our vertex input, which we'll call v. Okay, so that's our vertex output function, and then finally we need our fragment function. So these are working on all of our pixels. So this will run for every single pixel that comes through on the screen. So if you overload this part of the function, this is where things will start to actually lag. But for what we're doing, we won't see any problems. I'm going to want a fixed for frag, and I'm going to pass in my vertex output, which I'm going to call I, and this is going to be a single value target. Okay, perfect, and that brings us down to our NCG, and then at the end of this, just tidy these brackets up a little bit. As always, if this does end up not working, to make sure that we don't actually render out nothingness, we're just going to fall back on the diffuse value, so we get something, if not what we want. So that's basically the shell of most shaders. You don't need all of it, but that's pretty much the shell of it all. So we'll start filling these in. So for our properties, again, I'm just going to kind of copy paste these and talk you through them. So we're just going to need a color. We're setting this to green on our RGB value with an alpha of 1. A main texture, a range value which we're going to use to actually multiply out the depth texture to make sure that it's light enough when we can see it, a color multiplier, and a color mask. These we'll come back to. In the subshader is where we can actually set initially, just between our subshader and our pass, we can actually set our Shader Lab settings. So if I drop in the ones that we're going to use culling off, which is going to turn off any backface culling, so all of our faces are going to get drawn. To test the depth on, we are going to turn Z-Write off, so we're not actually going to write our pixels to the depth buffer, we're just going to take their values, and we're always going to test for Z testing. Okay, so once we've got those set, we can actually come down straight into our user-defined variables. So user-defined variables. So these are everything that we're going to need throughout the code following, certainly in our fragment function where we actually start manipulating the pixels. There we go. So we're going to want a texture input, color mask, basically all the things that we had from up here, along with a couple of others. So for example, our camera depth texture we're going to need to assign. Most of these are kind of floats or doubles. We've got a fixed 4 for our color. Fixed 4 is actually a 1/256 precision. It's the one that's most optimized for floating types. They're pretty good for colors because colors don't usually go outside of 1 and -1, so they work really well for that. So now we've got all of those. The uniform isn't actually required, so this would work just as well. We don't need that in there, but it's a really good habit to get into if you ever plan on taking shader knowledge away from Unity and into something like Maya or any other kind of software, to be honest. But yeah, in Unity we could take that out, it would work just fine. Okay, cool. So going down to our vertex input, we're going to need to assign some operators to both our vertex and our UV. The position and text coords are called semantics. and they're always going to contain information like the normals, vertex positions, texture coordinates, that kind of stuff. So we're going to assign a vertex and a UV to the positions and the texture coordinates. In the output, we're going to take both of those and a third. So if we pop these in the output, the single value position is the output position from the GPU to Unity's screen. So we've got now an output of the vertex, a UV and a UV depth, which we're going to come back to again later. Excuse me. So moving straight down through to the vertex function, the vertex function passing in that that vertex input starts as an object, so we're going to make it call it O, and this is the new function from Unity that transforms a point in the object space in the three-dimensional world to a space in the camera's clipping plane. So it makes it a 2D image out of a 3D world. The old version in Unity you'll probably see kicking around in other tutorials, which was the multiply of the Unity matrix MVP. If you type that in, it still works. It will just change it and give you a note at the top. But obviously rolling with the changes, this one I think actually makes a little bit more sense in terms of syntax. It reads a little better. And then we're just going to assign our UVs and just return our output, which is where we get on to the fragment function. Now, the fragment function is a little bit more in depth, so this is where we're going to start sort of picking the pixels apart. So if we do this one by one, first off we're going to want to get our depth from the camera depth texture. That depth, however, is just going to give us a floating point value. It's not going to be between 1 and 0, it's going to be whatever the depth is. So we actually want a linear depth, which we can get using Unity's built-in linear 0-1 depth. But if we just use that on its own, it's going to be really quite a dark scene. So what we want to do is almost make that a percentage of our range that we set earlier on at 0.01. So if we change the linear depth to a maximum of between 0 and then essentially a percentile of the linear depth, that's going to brighten our image up quite a bit. Following that, we want to grab our texture from the top, so we've got something to actually paste it onto. We will want to grab our color mask. We haven't assigned this in the inspector yet, but you'll see what that's for shortly. And then we just want to do some basic calculations on the actual colors. So we've got everything we need now. We just need to kind of play around with them. So within here, I've actually got another function which I'll explain in just a second. You'll notice, however, Unity itself, once you get into the CG program, it doesn't have like an IntelliSense. So although I don't have this function yet, I've got no red lines. If I were to go back into Unity now, the whole screen would just be pink, and I wouldn't get a lot telling me what was wrong. So it can be very difficult within CG or Shader Lab if you make any mistakes or typos. They can be fun to find. But hopefully this should be okay. So finally, once I've got everything, my color is becoming the color that I've picked up from the texture, multiplied by our color multiplier plus our linear depth. This is actually going to give me essentially a grayscale image of a 2D version of my 3D world. Obviously I don't want grayscale, I want color in that. So what I'm going to return is going to be my green color from earlier. Let's just pop this in so we can see my green color from earlier, plus the grayscale, multiplied by the grayscale map that we've got, multiplied by my mask, which we're going to set up in just a second. So the only thing left I've got to do is just pop this luminosity function in, which I'll just pop in just above it so we can see it. This is just taken from online. Essentially what happens, because we're turning a 3D image or a 3D scene into a 2D grayscale, we don't see reds and greens and blues all equally, which is kind of what I want when I'm turning a grayscale into a flat image. I don't want reds and greens or blues showing at different depths to me. I want to see them all kind of equally, and because we've got different amounts of rods and cones in our eyes, somebody somewhere that's very clever has worked out that these are roughly the values that we need to multiply the red, green and blue by to actually flatten how we see the color at the intensity that we see the color. So multiplying the RGB by these values and then returning it by the color multiplier plus the depth is going to give us a pretty clean image, and then we multiply out by color of green and pop a mask on, and we should have a decent return. So that's our shader packed out. That should be everything that we need within there. So if we save that and head on back to Unity, and we can kind of piece this together. So we've got in our first person camera, we've got our night vision in, we've got our material on. Hopefully our material now, if we add our night vision shader to our material, we apply our color mask. If we apply just a default particle, that's going to give us a really nice kind of center with a fade out to the edges, which is kind of what you get with night vision. You can apply all sorts of things onto this. So if we just set a kind of a hazed green to this, you can kind of see what's going on down here in our material. So now if we hit play, we've got the functionality that we had before, but if we press R to go into first person and then N to go into night vision, we now get this kind of greeny kind of glow. I'm just going to make that slightly okay. And so obviously it's still really light in this scene, so I'm going to turn down the brightness and give us some stuff that we can see, and I'll be right back. Okay guys, so I've just gone into my settings and just turned down my lighting, and I've also added in sort of an additional box just here that you can't really see in this scene. In fact, you can't really see much that's facing away from the light in this scene anymore. Just to kind of show how dark it can be and exactly what the kind of the color multipliers and stuff are going to be doing. So now if we hit play, and from here, I mean, we really can't see anything in there. If we go into first person mode, and now if we hit our night vision, you can quite clearly see the edges and the kind of the box that I've added in, and a few of the details, which is really quite nice. Now if we were to look at the variables that we've placed out before, you'll see that the range is multiplying the brightness, so that really does only need to be a very, very small value to change how bright this thing goes. And then the color multiplier, again equally, is going to change quite how sharp that image is against backgrounds. The color masks and the color itself can all be changed to give a completely different view, but I think that's kind of a cool, very, very simple introduction to a shader, how they work and the basic makeup of them. Okay guys, that concludes our 4-part tutorial in Unity 5.6 for this character. Hopefully you've enjoyed watching and it's been useful. I've certainly enjoyed making it, and I hope to see you again next time.